last time we did axiom already axiom of connection.
Yes, sir.
And scheme. So today what we are going to have a look, we will have axiom of parallel and axiom of congruence. You have a axiom of parallel and axiom of congruence. In the way Hilbert has classified the things which I said previously.
Yes, sir.
So he has used some terms like congruence, between, and other statements. So how we can, what I should say, how we can relate them with his definition of plane, point, surface, and
Space.
and the corresponding relations which you are imposing or which you impose from Euclid sections. So how we define point and how we define line and how we define plane and how we define
Space.
space. That's. So today we are going to have take some code which might be known in your earlier classes, but still. So since we are following Hilbert, Hilbert's in this thing, so we just see or Euclid station. So axiom of parallels, what do you mean by axiom of parallels? If you remember, you might have heard in earlier classes. Right? Parallel lines
Never meet.
or through a given point in a plane, you can draw only one line which is parallel to that line.
Yes.
You cannot draw two lines which are parallel. So if you want to restate what you have heard, so you can say that in a plane alpha, there can be drawn. Through any point A, line outside of a straight line. So you have to be line.
Outside.
So this is to be emphasized. It's outside that straight line. It's not on that straight line, or it's not within the crossing that straight line. So in a plane, there can be drawn any point lying outside of a straight line A. One and only one straight line can be drawn. One and only one straight line which does not intersect A. So this is one part of the statement. So this line is called parallel to a given point A. So from this statement, there can be two statements which we can just infer from this statement. For example, this whole sort of thing is deductions. From this, you can deduce two statements. What are the two statements you can deduce? So, in a plane alpha, one statement A, in a plane alpha, there is always a straight line. There is always a straight line passing through A, which does not intersect it. So in a plane A, there is always a straight line which is passing through a given point, which does not intersect
A.
This is one statement. The second statement is it's a sort of also a statement that a sort of impossibility statement that only one straight line is possible. So only one line is possible.
Only one line is possible.
Which will be parallel, which can be parallel to that line segment, which is in a given point. So in a given plane, you can have in a plane there can be drawn through any point A, lying outside of the straight line, one and only one straight line which does not intersect A. So if there is a plane, so you can only draw one point which will not intersect this point, so which is presumed to be parallel. So in a given point, in a given plane, if there is a given line, only one line can be drawn which will not intersect this line. Or for statements, a given one line can be drawn which will not intersect this line on a given plane. The other part of the statement is that is the only one line can be drawn. So this is, you got my point.
But
So
there
in
might be infinite lines.
So it will not intersect, that's the point. The point is not going to, it's in the statement that only one line can be drawn through that point which will not intersect that line on that point. And there are not many such lines, only one line exists. So at least there can be one line or there is only one line on that side. I can say the same thing. So I will, this statement can be broken, this statement can be broken into these two statements. That is, in a plane there is always a straight line crossing through A which does not intersect A. Or only one straight line. So this is also known as action of parallels. It's a very important action, this action of parallels. In the history of geometry, Euclidean geometry, this is a very, so you read it later.
Yes, sir.
So here I would only emphasize. So you just memorize this fact and try to visualize it. What he wants to say.
Okay, sir.
So from this, there is a theorem. The theorem says that if two straight lines, A and B, the two straight lines A, B of a plane do not meet a third straight line C. If two straight lines A, B of the plane do not meet a third straight line on the third straight line, so it's understood. Line C in the same plane, they do not meet each other. Not meet each other. You might have, so if two straight lines A, B of a plane, if there is a plane,
Yes, sir.
two straight lines
Two points passing through A and B.
do not meet a third straight line C in the
Same plane.
in the same plane. So it's not that they are going to meet any other plane, any other line in this plane. They are not going to meet
At any point.
at any point.
So they are parallel.
This is another way of saying the same things. So you are stating a given fact from different ways. So that should be the thing, that you should reach where you started. That is consistency.
Okay.
So if you can state this thing in the same form, two straight lines do not meet at third straight line. So what the point is that the three statements are self-contradictory. You can from one statement you can go to other statement. From this statement you can go to
We reduce
this
these statements also.
So this has been, so that's why it's called, so it's a theorem itself. So always theorem, you can go from theorem, you can go to the
We reduce these statements.
action.
Actions.
Parallelize theorem. So that's the base statement. It's the deduced statement.
ठीक
It is the
reduced statement है
so from a deduced statement you should always come to the
Original statement.
which is called actions.
Actions.
So said actions are statements which are true, which we cannot
prove
Okay. Whether they are self-evident or not, we are going to postpone that debate.
ठीक
So that's another discussion. So that's it. So for if A, B had a point A in common, there would exist in the same plane two straight lines A and B path. So that's it. So the other thing is that he is trying to say that by this also called principle of contradiction. So if I'm going to read it, what he says that for if A, B had a point A in common, there would then exist in the same plane C two straight lines A and B, each passing through the point A and not meeting the straight line. This condition of efficiency, however, contradicts the second assertion contained in the part. So if we assume that, for example, if A and B had a point A in common, there would exist in the same plane two straight lines A and B passing through the point A and not meeting C. So this will contradict the second assertion. This will contradict second assertion that only one straight line is possible.
possible
So if you assume that there could have been 2 points, if you assume that there would exist the same thing with C two straight lines passing. So if you assume there can be two straight lines, not one straight line, A and B passing through a point A and not meeting the straight line C. So that's it. So we can read this paragraph and see that if you assume that there are not so if you assume, should you read it? You read it. It's a bit of short. This paragraph.
ठीक
So what he just assumes that if you can assume not this, if there are two lines,
Two lines,
that will contradict this assertion.
ठीक
So this is another way of saying that same thing. So if two lines are parallel, if parallel lines never meet, from this you can have these reductions. So from internal consistency, if you want to violate this postulate, third postulate, it's not allowed with this one. So this one, this is true.
Yes, sir.
Got the point?
Yes, sir.
Now there is another action that's called
Action of congruence.
Congruence. Congruence, you might be knowing intuitively. You might have studied.
Yes, sir.
Congruence is a sort of, you can say it's sort of equivalence.
Equivalence.
A sort of. But congruence is not equal. We have separate sign for congruence.
They are not equal.
Something is called equal. So equal means exactly equal. You can replace one with the other. When you say equivalence, congruence, so you are imposing same set of relations in one system and the same set of relations in the another system. And you assume those relations have sort of equivalence. You can say intuitively that's called congruence. But in this note, Hilbert has not tried to define congruence in different sentences. For example, you say what is bird? You say a bird is like sparrow. So this is not the definition of bird.
Yes, sir.
So in the same way, Hilbert also has not defined congruence in concrete terms. He is saying, what do you mean? The congruence is like this.
Why?
So what he emphasizes in the starting there are words like congruent, between.
Sabr.
So they are intuitive motions.
ठीक
So he has intuitively tried to define congruence. So what he says congruence, for example, if I state segments, he says segments stand in certain relation to one another. One segment means those points in the plane.
plan
Stand is in relation to one another, and they are described by the word. They are described by the word called congruent. So they are described. So segments stand in relation to one another, and they are described by the word
congruent
So what he wants to say, if you congruent. So if A and B are 2 points on a straight line, A and if A and B are 2 points on a straight line A, and if A prime is a point upon the same or another straight line. So if A and B are 2 points on a straight line A, and if A prime is a point upon same or another straight line, this is G, A prime.
is point in the center.
Then upon a given side A, side A prime, on a straight line A prime, we can always find one and only point B, so that the segment A, B and B are congruent to the segment. We can always find one and only one point B prime, such that the segment AB or BA is congruent to segment A prime. So if A and B are 2 points on a straight line A, and A prime is a point upon the same or another straight line A prime, this one.
ठीक
Then so if there are A and B are 2 points on a straight line A, and the other 2 points on the straight line A, and if the A prime is a point on the other straight line A prime, okay. Then upon a given side A prime on the side A, and we can find one and only point B, so that A, B or BR is congruent to segment. So it means AB is congruent. So it means that if we have if A and B are 2 points on a straight line A, and A prime is the point upon the same or the another straight line. And if A prime is a point upon the same upon the same or
another straight
straight line, A prime. Then from a given side A prime on the straight line A prime, we can always find one and only point B, which is like that A B is going. We can have this thing A and
B
A prime. Then upon a given side A prime on a straight line A prime, find a one and only point B prime, so that
A
B are 2 points on the straight line A and A prime is a point upon the same or the other straight line. we can upon given side A prime on the straight line, we can always find a point B prime on that so that the segment AB and B are congruent, right? That AB and B, AB or B, sorry, AB or B is congruent. So AB or
B.
B is congruent. So we can always find it. So if there is a given straight line AB, so there is another straight line which may be existing in this plane on the same plane or not.
Same plane.
What he wants to say, we can always find the segment AB which is congruent to A prime, B prime. So we can find it. It's a sort of equivalence. He has not defined congruence. So we can find if a segment AB who in a line segment which is from a given line and another segment A prime B prime which may be on the same line or it may not be on the same line. So in principle we can find it. We can find such that AB is congruent to A prime B prime. So we can say it's a
same plane.
In the same plane. In the same plane we can find it. And in the
Or
same
in
plane, that segment can exist in the same line or in the same plane. It's not necessarily to exist in the
Same line or in the same plane.
same plane or the same line. Both straight lines. So it means we can find a segment AB is congruent to A prime, B prime. Or there is another inference you can draw from this. AB is congruent to AB. Given line segment is congruent to itself. You can also the same thing. And it can have a congruence. You can also construct a equivalent line segment. So this is it seems to be a self-evident statement, but if you want to write say the same statement in the common sensical terms, what we are saying is that every segment can be laid off upon a given side, upon a given side of a given point.
Is it possible to have another line A prime B prime in the another plane which is congruent to AB?
That's also possible. That's also possible.
Another plane.
Another plane.
Yes, sir.
So we are going to see it, but the geometry should be Euclidean.
Geometry should be. Yeah, that is right.
But if
Geometry was
that
not Euclidean.
the relation to the whole, if the geometry is not Euclidean, it's another subject.
Yes, sir.
But in Euclidean geometry, you can always
One plane is
there's a
Euclidean.
possibility. It's not that you can it's always possible to find. It's not that you can find. It's always possible to find. This is the way this statement is stated. So every segment can be laid off upon a given side of a given point, of a given point, of a given straight line, of a given straight line in one and only one view. Every segment can be laid off. So laid off means if you take this line segment and superimpose it on some another. Every segment can be laid off or taken away upon a given side. We take it from one side of a given point of A to a given straight line in one and only one way. So here it's only one way you can do it. One means you graph it, take this one. Okay. So if there is this thing AB, AB can be made equivalent to this if you can superimpose it on it. It's only one and only one way. That you can do it.
Yes, sir.
There is no other way. There is
No other.
no other way. So that's the point. So from this, there are other things you can also have. The other thing is, for example, again, so if a segment AB is congruent to A prime, B prime, if a line segment is congruent on another line segment, and this line segment is congruent to another line segment without prime. So from this we can also see
AB is congruent to
A prime. So you can infer from this, you deduce from this.
Okay, sir.
So if it's a general statement, congruent statement, from congruent statement, these are deductions.
Deductions.
Deductions. And if AB and BC are two segments of a straight line which have no point in common, aside from point B. So that A and BC two segments of straight line A which have no points aside from the point B. And further A prime and B prime. So if you have just like we have A, B and B prime. We have A, B and BC. In the same we have A prime, B prime and B prime, C prime. Be two segments of same or another line, of same or another line. If that's that way, likewise, and no other point other than B prime is common, only B prime is common. Then from this you are having, if A prime, AB is equal to A prime, B prime, BC is equal to B prime, C prime, then AC is equal to A prime, C prime. From this you can deduce this. So if you want to understand it in terms of line segment that we want to see the diagram. For example, there are two lines, A and B, B and C, A prime, B prime, C prime. So if AB is equal to this, AB is equal to A prime, B prime, BC is equal to
B prime, C prime.
This means AC is equal to
A prime, C prime.
This is equivalent to this. You can have also this deduction. Although it might look this B is existing somewhere in between A and C. You can construct as many such points and impose these equivalence or one relations.
Yes.
Okay, that's the point. Now we are going to come to another thing. Another thing is so this is audience. So now we are going to come to the point how can get angles from line segments. On a given plane, we have a line segment, and we talked of how we can generate parallel lines. Only one point is required on a given straight line, which will have parallel lines. So other cases may be angles only, because two line segments, if they are not parallel to each other, they are at inclined at some angle.
Each other.
Whatever that angle may be. So two line segments, if they intersect each other, they generate angles. And how do you state? So we state the same thing in terms of rays. For example, a line segment, if you can not extend it both ways, that's a line segment. If you can extend it both ways, you can go to infinity.
Infinity.
So if it's only extended in one point, it stops. If it can extend in other point, that's called ray. That's called
Ray.
ray. Ray is the point where it stops, but you can extend it only. So an angle is something which is constructed that a given line segment has somehow stopped at one point, but you can extend it in another direction. Got it? So you do it. So if you have, if alpha is an arbitrary plane, alpha is an arbitrary plane, and at and t are distinct half-rays, are distinct half-rays, are distinct half-rays. Line in alpha, line in
Alpha.
line in alpha, or emanating from the point O, so that so as to form different part of two straight angles. So you can have an angle, for example, or distinct half-rays can have angle like this. If you extend these half-rays, you can construct an angle like this, HK. Two distinct half-rays, they meet at a point and they can form an
HK.
angle like this. And if you want to impose the way we imposed these relationship, concurrence relationship between 2 points or more than 2 points in a given plane, okay, such as A is equal to A prime, A prime is equal to A double prime, then A prime is equal to A double prime. If you impose those concurrent relations on angles also, you can write that in a given plane you can always construct from these two segments or half-rays line and alpha, you can construct concurrence relation in terms of angles also. You can use the same logic
Yes, sir.
here for a given plane. Got my point?
Yes, sir.
The way we did it for the general line segments,
Yes.
you can do it for the half-rays. Two half-rays meeting each other in a given plane. You can construct two angles which are congruent in the game same. Such that the sides, this is equal to
This.
this is equal to this or this is equal to
This.
that imposition we can do. Or we can do that is going to is one going to or it means every angle is if you this is the first thing you can construct a corresponding angle which is congruent. Or this means every angle is congruent to itself.
That is.
This thing.
Yes, it is.
Right.
That angle is congruent.
Maybe we said a straight line you can always construct this is equal to this. AB is equal to we said AB is equal to A prime
B prime.
and AB is equal to
AB. Yes, yes, sir.
you can extend the same logic here also. Or you can somehow shift it. HK in closing congruence you can flip this side. Flipping the side will not change the relationship of these angles. It is AB
Yes, sir.
or it's
ठीक
so the congruence relation will still hold. The congruence relation is
Still
fit for these two half segments, out of which an angle is constructed.
yes, sir.
So apart from this thing, you can also flip if there are different things you can have. And again, you can have that if there are angles HK is congruent to H prime K prime and H prime
K prime is congruent to H double prime K double prime.
This means HK is
Congruent to H double prime K double prime.
This is another deduction you can have. So from a given action you can have third, these are all deductions.
Yes, sir.
But these deductions can have logic which can be traced to a given action. Okay, this is to emphasize the point again. So again, the last one to study is that if in two triangles, A, B, C and A prime, B prime, C prime, the congruences if in two triangles A, B, C and A prime, B prime, the congruences are AB equal to A prime, B prime, AC
Is equal to A prime C prime.
A prime, C prime, and angle
BC
is congruent to angle BA prime, C prime.
Yes, sir.
Hold, then the congruences. So from this, if you compose like this, you can say that angle ABC is congruent to angle A prime, B
A
prime,
prime C prime.
and angle ACB is congruent to angle
A prime C prime B prime.
So you can have the logic of congruences to extend into angles also. So from this extension, you can just for two triangles, you can just extend it. So, but the triangles are constructed out of half segments. Half segments.
Half
One
segments.
half segment. This is another half segment. This is
Another half
another. But those half segments are lying in that given plane, also, which we have defined. Okay. And they don't have the parallel condition. Parallel condition is that given from a given point, you can
Yes.
only draw one parallel line. So they are intersecting. These lines are intersecting each other. So, but now if you can suppose one triangle, you have to have a cone. You can have a converse relation of another triangle. Okay.
Yes,
This is
okay.
A, B, C, is A prime,
B prime C prime.
and then you can impose these relations. Okay. What relations that's so what is saying that action 4, so to say. One here statements concerning the congruence of the segments of a straight line only. So they will be called linear actions. The other is congruence of angles, congruence of segments and congruence of angles. Contain statements about elements of plane geometry. So these are actions of congruence of angles, congruence of straight lines, congruence of straight lines and angles. Okay. These all are actions of plane geometry. They all constitute or actions of
Congruence.
plane
Geometry.
geometry. So we are constructing plane geometry. Okay. By angles, lines, line segments.
Yes, sir.
Okay. In a given plane.
Yes, sir.
So this is what we have done. So in the next class, we are going to see what are the consequences of this congruence and action of continuity, which is left in this
Also continuity.
action, and the consequence of it or deductions of it